There's a problem here. Let's discuss it. 25.1 milliliter of an HCl solution is completely neutralized by 36.2 milliliter of 0.25 m sodium hydroxide solution. What's the molarity of the HCl solution? 25.1 milliliter of an HCl solution is completely neutralized by 36.2 milliliter of 0.25 m sodium hydroxide solution. What's the molarity of the HCl solution? We are going to find the molarity of HCl solution in two ways in this video. First of all, we should write the chemical equation and balance it. This is the chemical equation: sodium hydroxide plus HCl. We get sodium chloride plus H2O. You can see on the left hand side 1 sodium, on the right hand side 1 sodium, on the left hand side 1 oxygen, on the right hand side 1 oxygen, on the left hand side 2 hydrogens, on the right hand side 2 hydrogens, and on the left hand side 1 chlorine, on the right hand side 1 chlorine. Now you can see the ratio 1 to 1. To react with 1 mole of sodium hydroxide, 1 mole of HCl is required. We know the volume and the molarity of the sodium hydroxide solution. Therefore, we can find the number of moles in sodium hydroxide solution. Volume of the sodium hydroxide solution is 36.2 milliliters. Volume. Molarity 0.25 m. Molarity 0.25 m. Molarity 0.25 m. Molarity means in 1 liter or 1000 milliliters of the sodium hydroxide solution, there are 0.25 moles of sodium hydroxide. In 1 liter or 1000 milliliters, there are 0.25 moles of sodium hydroxide. Now we need to find in 36.2 milliliters of this sodium hydroxide solution, how many moles of sodium hydroxide are there? In 1000 milliliters of the sodium hydroxide solution, there are 0.25 moles of sodium hydroxide. Therefore, in 36.2 milliliters of this sodium hydroxide solution, how many moles of sodium hydroxide are there? We can find the answer in this way: 0.25 moles sodium hydroxide divided by 1000 milliliters sodium hydroxide multiplied by 36.2 milliliters sodium hydroxide. 0.25 moles sodium hydroxide divided by 1000 milliliters sodium hydroxide multiplied by 36.2 milliliters sodium hydroxide. We should cancel out units. Milliliter NaOH, milliliter NaOH. Now we get 0.00905 moles of sodium hydroxide. That means in 36.2 milliliters of the sodium hydroxide solution, there are 0.00905 moles of sodium hydroxide. This is the chemical equation and ratio. I have written it here again. According to the ratio, to react with 1 mole of sodium hydroxide, 1 mole of HCl is required. Now we have 0.00905 moles of sodium hydroxide. Therefore, to react with 0.00905 moles of sodium hydroxide, how many moles of HCl are required? We can find the answer in this way. 1 mole HCl divided by 1 mole sodium hydroxide multiplied by 0.00905 moles of sodium hydroxide. We should cancel out units. Mole NaOH, mole NaOH. Then we get 0.00905 moles of HCl. That means in 25.1 milliliter of this HCl solution, there are 0.00905 moles of HCl in 25.1 milliliters of this HCl solution. There are 0.00905 moles of HCl. Now we have to find the molarity of HCl solution. We can find the molarity moles per liters or moles per 1000 milliliters. Moles per liter or moles per 1000 milliliter. In 25.1 milliliter of this HCl solution, there are 0.00905 moles of HCl. Then 1000 milliliter of this HCl solution, how many moles of HCl are there? It is molarity. We can find it in this way. 0.00905 moles of HCl divided by 25.1 milliliter HCl multiplied by 1000 milliliter HCl. 0.00905 mole HCl divided by 25.1 milliliter HCl multiplied by 1000 milliliter HCl. We should cancel out units. Milliliter HCl, milliliter HCl. Then we get our answer 0.36055177 molarity. But there are many decimal places here, but 2 or 3 decimal places are enough. Therefore, we can take our answer in this way. Molarity 0.361 m. We can write molarity as 0.361. Second method. We know the volume of HCl solution 25.1 milliliter, but we don't know molarity of this HCl solution. We have to find it. We know volume of this sodium hydroxide solution 36.2 milliliters, and we know molarity of the sodium hydroxide solution 0.25 m. HCl solution, we don't know molarity m. We know volume V 25.1 milliliters. Sodium hydroxide solution, we know molarity 0.25. Volume 36.2 milliliters. Now we have to find molarity of HCl solution. We can take this HCl solution as number 1 solution. We can take this NaOH solution as number 2 solution. there's no problem. If you want, you can take HCl solution as number 2, NaOH solution as number 1. There's no problem there. This is number 1 solution. Therefore, molarity of HCl solution we can take as M1, and volume of HCl solution we can take V1. Molarity of sodium hydroxide solution we can take as M2. Volume of sodium hydroxide solution we can take as V2. As V2. We took molarity of HCl solution as M1. We have to find it. We took volume of HCl solution as V1, 25.1 milliliters. We took molarity of sodium hydroxide solution 0.25. We took volume of NaOH solution 36.2 milliliters. Now we can create a equation like this. M1 V1 equals M2 V2. M1 we have to find it. We don't know M1. We have to find it. We need to find it. V1 we know 25.1 milliliters. M2 0.25. V2 36.2 milliliters. Now we need to find M1. Therefore, we should isolate M1 on the left hand side. Then 25.1 milliliter goes to the right hand side in this way. Now we have isolated M1 on the left hand side. Now we can simplify this and find the answer. I use my calculator. M1 0.3605577. There are many decimal places here, but 2 or 3 decimal places are enough. Therefore, we can write our answer as 0.361 M. Thank you very much for watching this video. Please subscribe our channel, then you can get new videos as soon as they are released. God bless you.